Hello my dear kids. Namaskara, ಹೇಗಿದ್ದೀರಾ ಎಲ್ಲ? So today we'll be learning about concentration terms. So what are these concentration terms? So basically the concentration terms are 4, and those 4 concentration terms, so the very first one is molarity, molality, mole fraction, and normality. So let's learn them one after the other. So the very first one, molarity. What is this molarity? The name itself says something related to mole and molar. Exactly. The concentration terms, as the concentration word explains, here you are learning the strength of your solution, strength of your liquid. The solution can be solid, liquid or gases. Yes, and the concentration terms also can be considered in any of the solutions, but for the related subject, the related syllabus according to the curricula, we will be focusing on the liquid solutions. Right? So when we consider the liquid solutions, so in liquid solution, when we say molarity, in molarity we consider any number of moles of solute, number of moles of solute. This small n represent moles of your solute. Okay, any number of moles of solute in liter of solution. That means when you take your liquid, when you are preparing the solution, first you have to take your solute, and then in that solute you have to add the solvent up to it reaches to a certain liter, depending upon the liter of solution where it has both solute and solvent. Is it very clear? Yes. So this number of moles of solute with respect to liter of solution is called as molarity. So usually what happens is they will provide some number of moles of solute or a few grams of any of the salt or the compound, and they'll ask to calculate what is the molarity of this solution, right? And in such cases what you have to do, let me take an example. You have some 25 grams of NaOH. Please listen to this very carefully. You have some 25 grams of NaOH, 500 ml of solution. Now you have to check what is the molarity of this particular component. How can you do that? Ma'am, you just now told that you have to consider number of moles and liter of solution, but where are the number of moles? How can you check for number of moles? Please note it down. We can calculate number of moles by given mass and gram molar mass of a chemical compound. We need to check for number of moles. So how can we check now? What is the given mass? It is 25 grams. And what is the gram molar mass of your NaOH? So for Na, the atomic mass is 23 plus. For oxygen, it is 16. For hydrogen, it is 1. In total, it comes up to 40. Very good. So 25 by 40, these are the number of moles of solute we have. So how much it will come? So it comes up to 62 approximate. So the number of moles are 0.62. Now please remember, molarity can be mentioned in capital M, molality can be mentioned in small m, mole fraction in chi. This is not x, but usually we listen this as x, so let that be. We can also call this as chi, and normality in capital N. So here number of moles are 0.62. Coming back to the numerical, we have 0.62 number of moles. Now how much of solution we have? The volume. Here we can say volume, and the volume of your solution is 500 ml. You can please make a note of the formula. molarity is equal to number of moles by volume if the volume is not in liters. Can you see here? We have it in milliliters, not in liters. We have to convert that to liters. We can multiply that with 1000 and it gives us m is equal to, what is n? 0.62 divided by, how much we have here? 500 of solution, 1000. So 5, 2, and what's the molarity now? And it comes up to 1.4 m. So the given solution for this data, the molarity is 1.4 molar. This is as simple as that. Okay. Similarly, let's go to the next one. You can please rewind the video, check everything in detail again. You will understand how we can calculate molarity. If they give it in grams or mass, you can convert first that into moles and then you can check for the molarity. If the volume is given directly in liters, you can go directly for number of liters. If they give it in milliliters, you have to convert that to liters and your molarity values are near you. Okay. Now let's go to the next concentration term, that is molality. So again, this is very simple, just the same way. Let me take the same example so that it is more clear. So let us have the same example. 500 ml, here I will consider 500 grams. Okay. So let's check. Why, ma'am? Why did you change the volume, liters into grams, mass? And if you check, this is not solution, it is solvent. Run your brain. What we call that? Horses of your brain. You will get what is molality. Simple as that. Here in molarity, we consider number of moles of solute in volume of our solution. But when it comes to molality, we have to consider number of moles of solute in kg of solvent. We should not consider the whole solution. We have to only check for the mass of solvent. So it is again very simple. Now, do we have number of moles of our solute directly? No. Again, what we have to do? We have to calculate number of moles. We just did that, 25 by 40. This is a molecular mass of NaOH. I am just repeating so that you have the clarity what type of numbers we are considering here. So this is molecular mass of solute. Right. So now this is the same thing, 0.62 or so. And now when you substitute that in this formula, it is 0.62 divided by 500. But here it is kilogram. And how much do we have here? Gram. Again, in such cases, we have to multiply this with 1000. Again, the molality here is 1.4 molal. And molality is taken in small m. Clear? That's it. So here we have to consider mass of solvent. In molarity, we have to consider volume of solution. Okay, so this is simple. Let's go to the next concentration term. The mole fraction. What is this mole fraction? Again, simple, my dear kiddos. It is nothing but, the name itself suggests, 1 mole. And in that 1 mole, there are fractions, number of pieces, and that is mole fraction. Ma'am, the name is there and you are telling the same thing. What does mean by that? I'll explain that. So consider this ball as 1 mole. Okay. And now I'm making many pieces of this ball. For now I have only 2 pieces. So if this is 1 mole, then in this 1 mole, these type of fractions are there, these type of fractions are there. What is the percentage or the mole fraction of this or this is called as mole fraction. So for example, I have 2 pieces here, right? Let me take this as a 1, okay, and this as 2, okay, and together they are 1. Then definitely these 2 pieces becomes less than 1. Then please remember always the mole fraction is less than 1. So You can make many pieces of anything and together they all sum up to 1. So if I need to check for mole fraction of this one part, okay, then I have to take the number of moles of this, how much it is by the size or the mass or whatever, with the total number of both of them, that comes up to N1 plus N2. Simple. And here, as I told you, the mole fraction of this and the mole fraction of this together, they sum up to 1. So this is how we consider mole fraction. Let me give one more example. We have one glass vase. Okay, I broke the glass vase. Imagine I just broke the glass vase. And in that glass vase, we have triangles, we have rectangles, we have diamond shape, we have many different shapes because it's a glass vase. It was broken in an unpredictable way. So now the number of triangles are there, the number of rectangles are there, or the number of diamond shapes are there. Together they are x1, x2, x3, x4, so on, and they are all coming up to equal to one vase. That's how it is. Simple, right? So this is mole fraction. In that case, when we consider for solutions, what is this mole fraction? So that means how much moles of a solute or a solvent is there in the solution, particularly that is considered as mole fraction. The next very interesting concentration term, that is normality. Normality, it holds its own importance in all the calculations of concentrations, because just like molarity, you can connect these two, molarity and normality. Here also in normality, you'll be considering number of mole equivalents. What is this number of mole equivalents? We will check that just after a few seconds. With respect to volume of solution, again, just like a molarity. And if the volume of solution is in ml, if it is in not liter, then we have to multiply this with 1000. So this is normality. What is this normality? What is equivalence moles? That we will check just now. Okay. So let me rub all these things here. Equivalent mass. To know normality, we should know what is equivalent mass. What is this equivalent mass? Just like different locks have different keys. Okay, try to understand this. One lock could be very big, very small, or a small number pad or kind of a lock or anything. It has different keys. One has a small key, one has a big key, one has 2 keys, one has 3 keys, one has only 1 key. Similarly, equivalent mass depend upon the condition where you are using it. Simple example is equivalent mass is equal to the atomic mass or the molecular mass. Atomic mass by its valency. So each element holds its own atomic masses and its valency. Depending upon that, we will have equivalent masses. So if I consider oxygen, so what's the valency of oxygen? 2, if I'm not wrong, and if you know it really well. So what is equivalent mass of oxygen? 16 by 2, it comes up to 8. For hydrogen, it is 1 by the valency of hydrogen is 1 and it comes 1. And chlorine, it is 35.5 and its what do we call valency is 1, so it is 35.5. Similarly, calcium, 40 is its atomic mass, its valency is 2 and it gives us to 20. So these are different equivalent masses. Okay, ma'am, we understood equivalent mass with respect to elements. But what about when this comes up with a salt or any of the compounds like NaOH, CaOH twice, or HCl, or let's take H2O. So what are the equivalent masses for these all things here? Now, so the molecular masses, you have to be aware of the molecular mass. Let me write the molecular masses first here. Molecular mass of NaOH is 40. molecular mass of calcium hydroxide is 2 atoms of oxygen and 2 atoms of hydrogen, and it will come up to 74. And what's the molecular mass of HCl? It is 35.5 plus 1, it is 36.5, and you know for water it is 18. Now when it comes to its equivalent mass, so for equivalent mass, here we have to check their relative oxidation states, or as we said, valencies. Alright, so we have to consider the one which is bigger. So here Na plus 1, OH minus 1, both are 1 irrespective of their signs. 40 divided by 1, the equivalent mass of NaOH is 40 again. Similarly, when it comes to calcium hydroxide, for calcium hydroxide, calcium is plus 2, OH is minus 1, but how many OH we have? 2. That means here the maximum oxidation state is 2, 74 by 2, and it comes up to 37. 35 plus 2. Okay. And then here H plus Cl minus 1, 1, 1 each. So that's the reason it is 36.5 by 1, and it is 36.5 itself. And for water, it is 18 by 1, and it is 18. So these are the equivalent masses. So when you calculate normality, when we consider molarity, capital M, we considered molecular masses, these masses. But when it comes to normality, you have to consider these masses which are equivalent masses. So let's solve one simple example. Let's recall a bit. You can rewind the video for the formula, or let me write it again. So normality is equal to number of moles of equivalent by volume of solution. If your volume of solution is not in liters, then we have to consider into 1000. Let me consider calcium hydroxide. I have calcium hydroxide of some, let me take it as 37 grams. And I have 500 ml of solution. Okay. Now solve and check what is the normality of this particular solution. It's again very simple. We have to consider number of equivalent masses. They have given mass. First check number of equivalents. Number of equivalents is equal to given mass by gram equivalent mass. Please make a note of this formula as well if you want. Then number of equivalents here is equal to given mass is 37 divided by what's the equivalent mass of calcium hydroxide? 37 itself. So how many number of equivalents we have? 1. Just for your better understanding, let's calculate molarity as well. Okay. So to calculate molarity, number of moles by volume into 1000 if the volume is not in liters. So given mass, the number of moles we have to take, not equivalents. So N is equal to given mass is 37, but the molecular mass is 74. Here we have to consider the molecular mass for molarity. Equivalent moles for normality. Hope it is clear. That means here it becomes 0.5. Correct? 1 by 2. 0.5, and let us take 500 ml the same solution into this. So it comes up to 1 molar. But normality, will it be same? No, it will not. So how can we do that? So here it comes up to number of equivalents are 1 divided by given mass of volume of solution 500 into 1000. So the normality is 2. Now from this and this, what did you understood? Can we connect this normality and molarity together? Yes, it's as simple as that. We can connect the normality and molarity. Hope you understood this part by solving this example. I just wanted to keep it there. I'll just rub it. We will see the connection between the normality and the molarity. So normality is equal to molarity into equivalence. Please make a note of this formula as well. This gives you the idea how much normality you can get if you know the molarity and the equivalence. Equivalence is nothing but oxidation state when it is an element, and it is a relative charge or the number of exchange of electrons when it is a salt or any of the compounds. So this is as simple as such. So I just give you one idea here. Please do make a note. You can just start reading any of the chapter of physical chemistry. When you start analyzing or going through the synopsis of physical chemistry chapter, please keep a page there, just a one A4 size sheet or a note page or something like that, and you can start noting down every single formula by the time it is coming your way while you are revising or reading or started doing any of the physical chemistry chapters. So when you make a note of those formulae, you have a formula sheet ready for you. Lots of your work is done. You don't need to run for the resources from different books. You do have your own formula sheet. So when you have that formula sheet, whenever you are solving numericals, you can grab that formula sheet and you can check what formula is required in the initial stage. Without by hatting, you can solve the problems. And when you are very much clear about how to solve the problems, which formula to be used, then no doubt you don't require that sheet as well. That's how you have to do. For more competitive type of questions, for any particular question solution, you can DM, you can comment, and you can get one-on-one session for that. You can get clear depth classes on all the concepts of chemistry related to undergraduates or graduates and competitives like JEE, NEET, and any other competitive or more such videos. Please subscribe our YouTube channel, click on the bell icon for notifications, and follow our page on Instagram as well. Thank you so much.